Hey everybody, Mr. Larson here. So you guys just went through meiosis, the different steps and how it all works together to create those sex cells, those gametes. But now we're going to be looking at what happens when something goes wrong during meiosis and the effects that it could have on the child that it eventually creates. So first we need to know basically how scientists are able to figure this out. So scientists can make what is called a karyotype in order to figure out how many chromosomes are in the person or a developing embryo. So this is a test that almost every single doctor goes through, especially in the United States, because they want to make sure that that baby is happy and it is healthy. So what they're looking for are what are called trisomies, or what basically is 3 chromosomes, or a monosomy, which is only 1. So these things do happen in an embryo or in a person where they only have 1 or 3 of a single chromosome, where we're supposed to have 2. So an example of this is when a developing embryo has 3 copies of chromosome 21. That is what causes Down syndrome. So that is one reason. So that is the reason why that Down syndrome genetic disorder happens. So this is an example of what a karyotype looks like. Here you can see the different pairs, all the way up from 1, 2, 3, all the way through. And down here you can see that they have discovered 3, or what is a trisomy of chromosome 21. So this is what doctors do. They look at the different chromosomes to make sure that they match and make sure that there are no genetic defects that they can see in the specific chromosomes. In this one, this is an example of a person with Down syndrome. So now, why does this happen? Why does, where we're supposed to have 2, why do we have 3? So it's a process called non-disjunction. Basically what happens during meiosis is when they are supposed to split, they unfortunately don't. So actually both pairs or the pair of chromosomes goes to one cell, where the other cell doesn't have a single chromosome. So now this is basically, this happens during meiosis, unfortunately, and parents are able to figure this out by doing a couple of tests here shown below. Now, during this process of karyotyping, not only can you figure out if there are genetic disorders with the child, you can also figure out the sex of the child. Now, there are 23 different pairs of chromosomes. 22 of them are what are called autosomes. So autosomes are basically everything else beyond every other genetic information, where the last pair of chromosomes are called sex chromosomes. So this is what basically determines one's sex when they are born, basically the physical characteristics of their sex. So in humans, X is the full chromosome, Y is kind of the smaller version. We'll see a couple examples here. Each gamete, each egg cell, each sperm cell either has a X chromosome or a Y chromosome. Now, every single egg only has an X chromosome, while sperm can either have an X or a Y. We'll talk about that here in a little bit, why that is the case, where the eggs, or what is coming from the female, always has an X chromosome, and then what is coming from the male can either have an X or a Y chromosome. So here we can see kind of our reasons why. So all females only have, or if you are female, you only have X chromosomes. So 2 X chromosomes are the most common for female. 3X or 1X will still be female, but there are some genetic disorders that go along with that. The XY chromosome pair is the most common for a male. But there are also possibilities to have XXY, XYY, and all these situations that happen with the sex chromosomes. But these will all cause some form of genetic disorder that go along with it. If you only have a Y chromosome, that child will unfortunately not survive, just because it doesn't have the full genetic material that is provided from the X chromosome. So here are 2 examples of karyotypes. One is male, one is female. You can tell by looking at the sex chromosomes here at the bottom right. So this is a baby who was born with the female physical characteristics, and then this is one that has been born as a male with those physical characteristics. So you can tell by the larger X chromosome and the smaller Y. So you can tell that there is a significant difference between those two chromosomes. Now, we've kind of looked at these already, but mutations do cause genetic disorders. So there are those that are deletion, where an actual part of a chromosome is completely gone. Duplication, where a chromosome breaks and then actually attaches to a different chromosome, basically doubling the amount of information on that single chromosome. Inversion, kind of talked about it before, where basically a piece breaks off, flips, and then reattaches. And then translocation is basically where a piece of a chromosome goes to a completely different chromosome altogether and can cause serious problems down the line. So now we're going to go through a couple more different genetic disorders that happen when looking at your chromosomes. So once again, a trisomy 23, or you have three chromosomes in the 21 pair, both here and here at the bottom, cause these different physical characteristics. So these are the physical characteristics of somebody with Down syndrome. That trisomy is basically what causes these genetic disorders. Another one is Turner syndrome, where there's only one X chromosome. So the doctors only find one X chromosome during the karyotype process, and this is what basically the genetic disorder is. So symptoms from Turner syndrome are neck webbing, shorter stature, or barreled chest, some heart defects, among other things. So this happens with about 2,000 to 5,000 females. Now, next is Klinefelter's. So this is a more common genetic disorder. This is the most common sex chromosome disorder that happens. So basically, you can see here at the karyotype down below, when you're looking at the sex chromosomes, they have two X chromosomes, and then one Y. So that is what causes Klinefelter's. Here you can see again another genetic disorder with the sex chromosomes. You have one X chromosome and then two Y. Each of these is also a similar disorder to Klinefelter's, but has some slight differences to that disorder. There's also what is called intersex and androgen insensitivity syndrome, basically meaning that the child is genetically born male, but has a hormone insensitivity, so they could actually have female reproductive anatomy while having those male chromosomes. Now, at this time, parents and doctors are put in the position to decide whether to perform surgery to designate the sex of the child or to allow that child to decide later on in life what they want to go with, if they want to change at all. So just as basically culture has developed and become more progressive, we have, as a culture, have decided to wait until the child develops further to allow that child to develop or to identify themselves as one of the sex or gender. Basically, this is a discussion that's been going through medicine, genetics, as well as in our culture in general. Now, genetic identity can either be related or unrelated to these biological processes. So sometimes it's related to your sex chromosomes, or it could basically just be up to the child itself, which you may have experienced with either your friends or yourself, or somebody who has gone through this process. So basically, this is just the overarching idea of what happens with genetic disorders with sex chromosomes, and how sometimes meiosis can cause problems later on with the child. So I hope this was interesting. Please let me know if you have any questions, and move forward with the digital lesson. I will see you guys soon.